When setting up a 200-volt neutral transformer, there are several key specifications and considerations to keep in mind. Firstly, voltage is the most important aspect. The equipment requires a 200-volt neutral supply, meaning the line to neutral voltage should be 200 volts. Secondly, frequency is another vital consideration. Verify with the customer whether the equipment is compatible with 60 Hz, which is the United States standard, or 50 Hz, which is the European standard. Using the incorrect frequency can damage the equipment. Thirdly, determining the power rating of the equipment is crucial to ensure the transformer has sufficient capacity. Check the equipment's documentation or nameplate for its volt, ampere, or wattage requirements. Once you know the required specifications, you can begin searching for appropriate transformers. One option is to contact local electrical supply distributors that specialize in transformers. These distributors can provide expert advice and a range of transformer options. Another option is to search online retailers such as Amazon, Grainger, or Allied Electronics for 200-volt neutral transformers. Be sure to carefully review the specifications of any transformer you find online to ensure it meets your needs. A third option is to reach out directly to transformer manufacturers like GE, Siemens, or ABB for custom solutions. These manufacturers can provide transformers tailored to your exact specifications, but this may be a more expensive option. Safety precautions are paramount when working with electrical equipment. One important precaution is grounding. Ensure the transformer is properly grounded to prevent shock hazards. Connect the grounding wire from the transformer to a suitable grounding point, such as the grounding electrode or the electrical panel's grounding busbar. Another important precaution is wiring. Use appropriately sized wiring to connect the transformer to the equipment and power source. Consult the National Electrical Code, specifically Table 310.15b16, formerly 310.16, for the appropriate wire gauge based on the amperage and conductor temperature rating. Thirdly, ventilation is important. Provide adequate ventilation around the transformer to prevent overheating. Do not enclose the transformer in a small, unventilated space. Fourthly, labeling is important. Clearly label the transformer and connected equipment with the correct voltage and frequency information. This will help prevent accidental misuse or damage. Consider these additional notes. Check with your local electrical inspector or code enforcement office for any specific requirements or permits that may be needed for installing a 200-volt neutral transformer. The cost of portable transformers can vary depending on the power rating and features. Get quotes from multiple suppliers to compare prices. Consider purchasing a transformer with built-in surge protection to protect the equipment from voltage spikes. Surge protection can help prevent damage to the equipment from lightning strikes or other electrical disturbances. Selecting the right transformer requires attention to detail. You'll need to confirm the equipment's voltage and frequency requirements along with its power consumption before you can find a suitable transformer. Let's look deeper into these elements, starting with a discussion of voltage. Transformers are often used to step down higher voltages to lower ones. The primary voltage is the input voltage, and the secondary voltage is the output voltage. In this case, a transformer is needed to convert the available voltage, which may be 240 volts or 480 volts, down to 200 volts. Transformers operate based on the principle of electromagnetic induction. They consist of two or more coils of wire wound around a common core. When alternating current flows through one coil, called the primary winding, it creates a magnetic field. This magnetic field induces a voltage in the other coil, called the secondary winding. The ratio of the number of turns in the primary and secondary windings determines the voltage transformation ratio. For example, if the primary winding has 240 turns and the secondary winding has 200 turns, the voltage transformation ratio will be 240 divided by 200, which equals 1.2. This means that if the primary voltage is 240 volts, the secondary voltage will be 200 volts. It's also necessary to understand frequency. Electrical frequency refers to the number of cycles per second of an alternating current AC signal. It is measured in Hz. In the United States, the standard electrical frequency is 60 Hz, while in Europe, it is typically 50 Hz. The frequency of the power supply must match the requirements of the equipment being powered. Using the wrong frequency can cause the equipment to malfunction or even be damaged. Some equipment is designed to operate at either 50 Hz or 60 Hz, while other equipment is designed to operate at only one specific frequency. Check the equipment's documentation or nameplate to determine its frequency requirements. If the equipment is not compatible with the available frequency, a frequency converter may be needed in addition to a transformer. Frequency converters change the frequency of the electrical power supply. They are typically used to convert 50 Hz power to 60 Hz power, or vice versa. When sizing a transformer, it's necessary to consider the power consumption of the equipment. The power consumption of electrical equipment is measured in watts or volt-amperes. Watts are a measure of the real power consumed by the equipment, while volt-amperes are a measure of the apparent power. The apparent power is always greater than or equal to the real power. The difference between the apparent power and the real power is due to the power factor. The power factor is a measure of how effectively the electrical power is being used. A power factor of 1.0 indicates that all of the electrical power is being used effectively, while a power factor of less than 1.0 indicates that some of the electrical power is being wasted. To determine the appropriate size of the transformer, you need to know the volt-ampere rating of the equipment. This information can typically be found in the equipment's nameplate or in its documentation. Once you know the volt-ampere rating of the equipment, you can select a transformer with a volt-ampere rating that is equal to or greater than the equipment's volt-ampere rating. It is always better to select a transformer that is slightly oversized than to select a transformer that is undersized. An undersized transformer may overheat and fail, while an oversized transformer will operate more efficiently and last longer. Now let's dive into some different options for finding the correct transformers. Electrical supply distributors are companies that specialize in selling electrical equipment and supplies. They typically carry a wide variety of transformers, including 200-volt neutral transformers. Electrical supply distributors can provide expert advice and assistance in selecting the right transformer for your needs. They can also provide installation and maintenance services. Some popular electrical supply distributors include Graver, Rexel, and Platt Electric Supply. Online retailers are another option for finding 200-volt neutral transformers. Many of online retailers, such as Amazon, Grainger, and Allied Electronics, carry a wide variety of transformers. Online retailers typically offer competitive prices and convenient shipping options. However, it is important to carefully review the specifications of any transformer you purchase online to ensure it meets your needs. Be sure to check the transformer's voltage, frequency, and volt-ampere ratings. Transformer manufacturers are companies that design and manufacture transformers. They can provide custom transformer solutions tailored to your specific needs. Transformer manufacturers typically offer a wide range of transformer types and sizes. They can also provide engineering and technical support. Some popular transformer manufacturers include GE, Siemens, and ABB. Next are some safety precautions. Grounding is the process of connecting an electrical circuit or equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Grounding is required by electrical codes in most countries. To properly ground a transformer, connect the grounding wire from the transformer to a suitable grounding point, such as a grounding electrode or the electrical panel's grounding busbar. The grounding wire should be sized according to the electrical code requirements. Wiring refers to the conductors that carry electrical current from the power source to the equipment. The size of the wiring must be appropriate for the amount of current it will be carrying. If the wiring is too small, it may overheat and cause a fire. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate wire size for different applications. Consult NEC Table 310.15b16, formerly 310.16, for the allowable ampacities of insulated conductors. When connecting the transformer to the equipment and power source, use appropriately sized wiring and follow all applicable electrical codes. Ventilation is the process of providing fresh air to an enclosed space. Ventilation is important for transformers because it helps to dissipate heat. Transformers generate heat as they operate. If the heat is not dissipated, the transformer may overheat and fail. To provide adequate ventilation around the transformer, do not enclose it in a small, unventilated space. Ensure that there is adequate airflow around the transformer. You may need to install a fan or other ventilation equipment to provide adequate ventilation. Labeling is the process of identifying electrical equipment with its voltage, frequency, and other important information. Labeling is important for safety reasons. It helps to prevent accidental misuse or damage to equipment. Clearly label the transformer and connected equipment with the correct voltage and frequency information. Use permanent labels that are resistant to fading or damage. Checking with local electrical inspectors or code enforcement officers is an important step in ensuring that your transformer installation complies with all applicable electrical codes. Electrical codes are designed to protect people and property from electrical hazards. Local electrical inspectors can provide guidance on the specific requirements for your area. They can also inspect your installation to ensure that it complies with the code. The cost of portable transformers can vary depending on the power rating and features. Get quotes from multiple suppliers to compare prices. Factors that affect the cost of a transformer include its voltage, frequency, volt-ampere rating, and efficiency. Higher efficiency transformers typically cost more than lower efficiency transformers, but they can save you money in the long run by reducing your energy consumption. Consider purchasing a transformer with built-in surge protection to protect the equipment from voltage spikes. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage spikes caused by lightning strikes or other electrical disturbances. SPD work by diverting the excess voltage away from the equipment and into the ground. SPD can be installed inside the transformer or as separate devices. When selecting an SPD, be sure to choose one that is rated for the voltage and current of the equipment being protected. Ensure that the transformer is installed in a dry and well-ventilated location. Transformers should not be installed in areas that are subject to moisture or excessive heat. Moisture can damage the transformer's insulation and cause it to fail. Excessive heat can also damage the transformer and reduce its lifespan. Regularly inspect the transformer for signs of damage or wear. Check the transformer's wiring, connections, and insulation for any signs of damage. If you find any damage, have the transformer repaired by a qualified electrician. By following these guidelines, you can safely and effectively set up a 200-volt neutral transformer for your equipment. Remember to prioritize safety and consult with qualified professionals when needed. Be sure to disconnect the power supply before working on any electrical equipment. Never work on electrical equipment while it is energized. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical equipment, hire a qualified electrician to do the work.